that we played leading up to the webinar, you can always click on this widget for more information on how to use your console and access other webinar resources, such as today's slides. If you're enjoying what you're hearing, feel free to give a heart or a thumbs up using the reactions widget on your console, looks like a smiley face, and don't forget to submit your questions for our live Q&A at the end of the presentation. When print providers rely on physical standards and subjective comparisons, they often face customer rejections, slower turnarounds, and time and material waste. On the other hand, moving to digital, standards-based quality control can eliminate subjectivity, enhance accuracy, and reduce waste in your workflow. Today, you'll hear about various color management solutions to digitize your workflow and help you achieve more cost-effective and sustainable print production. Mark Gundlach, architect at X-Rite Pantone, will be leading us through how to identify where in the color maturity continuum your operation falls, how to digitize and connect your workflow through tools and best practices, and how to reduce costs and minimize waste through color control. And Robert Jameson, plant manager at American Packaging Corporation, will give us a real-world look at exactly what all of this means in a live environment. So now, Mark, I'm going to hand it over to you.
Thank you very much. So I'm going to turn off my camera here so you can focus on the slides. Alrighty, so color is a real critical component to packaging. The use of color is intended to influence the buyer of the product. For some products, incorrect color could imply that the product is not fresh or it's even counterfeit. Consumers will consciously or subconsciously choose an alternative product based on unexpected color differences. Print buyer color approvals can include the shipping of samples back and forth or even travel for press approvals. And with brands looking at their environmental impact and the need to increase sustainability, all aspects of production must be scrutinized for waste. Color issues are responsible for up to 60% of rejected packaging production. This increases the cost for the brand and the supplier. It increases the amount of wasted material that must be sent to the landfill, and more resources must be used to produce the replacement packaging. With proper use of visual and digital tools, a lot of this waste can be removed from the process. So near the beginning of any print project, the desired colors are specified. And in some cases, these colors are not communicated well throughout the supply chain. In other cases, the desired color is simply not achievable with the inks or substrates, but the unachievable color is specified anyway. So in each step, there's a chance that an ambiguous color description or the production limitations are going to lead to a shift in the color and ultimately disappointment. However, with better planning for achievable color specifications and unambiguous color communication, the result can be a more predictable and repeatable product. Let's look at the sources for the problems and the solutions. So at the basic levels for color evaluation, visual assessment is used, but it requires the proper viewing conditions and can be very subjective when considering what is good enough. Adding instrument evaluation reduces the observer bias. The next level of color maturity is where they start to use instruments and software to capture the data, to take advantage of more advanced tools for correction. Then using this data for further assessment for process improvement and communicating color across the supply chain digitally without the ambiguity of physical standards that we're going to talk about later. It really comes together when you add automation that uses the data to allow for faster make-readies in QC.
Hey, Mark, I hate to break in real quick, but we've had a few people say they can't see your slides. So could you try turning your camera back on and see if that pops your slides back up?
Absolutely. How about now? Can you see my slides now?
I can see them. Let me...
Were you able to see them before?
I am going over to the audience view. There's a quick delay, so hopefully hopefully that has got them. I'm seeing a thumbs up, so I think that we are getting slides again.
Okay, well then I'll leave the camera up. Okay. All right. So let's move on. So let's start with looking at what proper visual assessment looks like. Visual assessments have their place in controlled lighting and understanding the limitations. The color of the light source has a huge impact on the judgment of color. Viewing these printed samples under different lighting conditions leads to very different decisions. Incandescent home lighting is less common, but still exists, and wrong lighting can lead to incorrect color moves on press and disputes over color matching and possible product rejections. Viewing works better when it's aligned with the instruments with what the instruments are seeing. ISO 3664 is the graphics industry viewing condition, and it's aligned with the color measurement conditions that are for our instruments, which is ISO 13655. Don't worry, you don't have to memorize all these numbers, but I just want you to understand there are ISO standards that describe the way the viewing conditions should look, as well as the way instruments should be reading those colors. For production areas, it's important to have a good, well-maintained viewing booth or fixture at the press. This includes replacement of the lamps based on the manufacturer's recommended hours of use. Just because it still lights up doesn't mean that they are putting out the correct light. For additional quality evaluation, quality departments often have a dedicated viewing booth or box to view under additional lighting conditions. For example, some brand owners may also specify that the printed package must be evaluated under D50, as well as store fluorescent lighting. In some cases, it's useful to see how the product packaging will look under traditional incandescent lighting. Some systems even have UV light sources, so you can see the impact of the optical brighteners on the paper. With the physical guides, there are limitations that we want to make sure you're aware of. So fan decks and other printed guides are usually produced on a printing press of some sort. So there's naturally going to be some variation of one type of another. Even though these are produced with very tight tolerances, no two are absolutely identical. Then there's the ink room proofs, and those may not be very uniform even across the proof. You need to be careful about user subjectivity when you're dealing with the light standard dark guides that we used to use. They're fairly common. See them a little bit less nowadays, but they still exist. Key there is that the light and dark examples are the limits of acceptability. They're not optional targets. Be aware that ink is going to fade and the paper is going to yellow. Over time, these standards are subject to fingerprints and dirt. All physical guides are prone to these limitations and can lead to miscommunication and unmet expectation. That's why we must maintain the digital standards for use within the instrument and the software for QC. So here's a big one for you. Density is not a standard. Many press operators have recognized that you can't control press effectively visually, and they do rely on their instruments. However, density alone can also lead to waste in production. Density and color strength are control metrics on press, but they don't tell you what color you're producing, and they're not print standards. So in these examples, the densities have measured the same, but the appearance doesn't match. So how can that be? Well, when the ink colors or the dot gain drift out of tolerance, the density is not going to tell you that the appearance is wrong. These three images here, as you can see, we've got all the same density achievements here. Okay, so they match across the board. However, on the left side, you can see your TVI is too high. It throws the color off. On the right side, you can see the actual ink hues are a little bit different. So even though we hit the same density, the hues are different, so it changes the color cast. Density can be used to maintain a production run. Density measurements alone will not assure that the printed product will be usable, however. This can lead to rejection and landfill waste. You need LAB for make ready and to diagnose color problems. The CMY ink LAB values here are very different. Let's take a closer look at just one ink, okay? So we measured 3 real yellow ink samples and got these results, okay? Can you visualize the difference in these patches? So our target here is a density of 105. The first patch is very close to that target density. Well, so is the second one. So you'd expect that they would visually match. Well, they don't. And then the third one, well, based on the density, appears to be lighter, but is it? When we look at the measured color differences, we see a different story. The 2 patches on the left are not equal color matches as the density implied. The deltas are very different for the color. And now if we look at the color patches more closely, we see that the patch on the right is not actually lighter as the density value showed, it's darker. This is because of the way that density is measured with specific filters for each primary within the instrument. The density for the yellow is lighter, but that doesn't consider the contamination of the color. In fact, if we tried to adjust the press based on the patch on the right, we would have increased the density of the yellow. If we relied only on density for this press run, the results could be rejected and sent to a landfill. So here's just some examples, some ISO standards and some measured values. ISO print standards only include colorimetric targets. They don't include density targets. In this example, we see the CMYK solids, the RGB overprints, and even the substrate colorimetric targets. Now, in many cases, the print buyer expects the printer to match a fingerprint run. Now, that would be measured from a run that's done prior to their production runs, and it may not align with ISO print standards, but the measured fingerprint data is then used to represent achievable colors on their press, and this should always be LAB target values, not density values. It's critical that the printer uses the same colorimetric target values that the prepress operators use for color separation and proofing. Now, for the midtone values, think about your images. They're not made out of solids, they're made out of tints. So TVI is going to have a huge impact on your images. Even if the solid densities are right on target, if your TVIs are off, your images are going to be off. The 2 images on the right have the same solid ink densities, but they look very different because the TVI is different. And all of the image color is carried by the tints. So for your tint values, those are covered by TVI or G7 metrics. So some regional print standards use standard dot gain or TVI target curves. G7 doesn't specify specific TVI target values. In fact, the TVI will be different based on the color of the substrate. This is because with G7, the tint values are all adjusted to compensate for the substrate color. For example, if the paper has a yellow cast, well, then the calibrated tints for the yellow ink are going to be reduced, and perhaps those for the cyan and magenta will be increased. In G7, the L star, or lightness of the black ink and of the CMY grays, is used to evaluate the tonality or lightness of the tint values. And the CH is measured to evaluate how neutral gray the patches are. The use of G7 is growing because it provides a better way to know if the printed image will appear too light or too dark, and if they're properly neutrally balanced. Measuring of TVI or G7 gray balance is critical to assure proper tonality of the tints in your production. So let's take a look at why we need digital standards for spot color matching. So if an ink proof is required for a customer approval, there's often a series of trials shipped back and forth before acceptable and achievable samples produced. And then in some cases, a printed color standard is then produced and shipped out to all the vendors. and they will vary in color by a small amount, but within a tolerance, but still different. The error stack is the result of adding the sources of error in a process. When working with physical visual standards, user subjectivity and physical differences add to the error stack. When each ink vendor receives a slightly different version, then measures it to make their own ink, things get a little further out of control. If the press operator is then given the same physical standard, or even worse, a new ink proof from their ink tech on site, then the color is going to drift even further. And then if multiple suppliers or plant locations are involved, the differences between the shelf product can be even greater. This is a real-world example. These printers were tasked with hitting the same physical standards that were shipped out. Each of the ink vendors did their very best to hit the color, but each ended up with a different direction from the original physical standard. They established their own press standards based on what they provided from their ink room. Their average delta E to their own standards was very low. As you can see, the values are clustered in there. However, when they compared the product from the 3 suppliers, they had deltas up to 3 delta E from each other. That's showing up on the shelf. That's looking different. That's the brand going to be upset. Digital standards can be distributed to suppliers, and they do not change. They provide an unambiguous specification. They should include more than just LAB values. They should include the measured spectral data. This provides the best information for formulating inks. Even digital standards have some risk if they're not controlled. You want to make sure that you're working with the true standard, not something that was measured by an unknown or unqualified source. Once the digital standard is produced and approved, that data is the one truth for that color. Common ways that users end up with invalid digital standards are when a supplier decides to measure something they produced, or some other sample or book, and then create a new digital standard. And this won't match the original standard, and thus production won't match either. Many brands like to specify their brand colors with Pantone because they can use the printed Fandex to visualize their colors. And then the books are similar enough that different viewers at different locations can pull out their books and see and discuss the colors from anywhere. And every printer and every supplier can understand what's being requested of them when they ask for a Pantone number. The cloud-based Pantone libraries contain the digital standards, and they're accessible by a variety of software tools to use in every stage of the process, from the design stage to the ink room to production to QC, to provide a constant communication of color throughout the supply chain. The printed Pantone Fandex represent specified ink colors as they can be reproduced on high quality, bright white coated paper. This happens to be an offset press. These can be easily reproduced on many offset press conditions, especially if running a bright white stock. If you're printing offset, flexo, or gravure on any similar bright white material, and if the inks you're using are capable of vibrant color, a good match is probably achievable. Things get a little bumpy when the desired color can't be reproduced on other substrates. What if your production is on, say, a white film or a clear white film, a clear film with a white ink backer, or a folding carton board, or any number of other substrates and materials that are different, have different characteristics, and then you have different inks on press that add to that problem. Some of these inks may have requirements such as rub resistance or food safety or color fade resistance. And some of these inks are not able to reproduce the wide range of colors as well. In some cases, the substrate is very different from the Fandex, and there's no way to get even close to that original desired color, like this brown craft on this cup sleeve. In this example, I might be able to reproduce the Pantone Master on my customer's bright white cup, but what about the brown craft sleeve? No way. So what if I'm producing the sleeve at 5 different suppliers or 5 different plants, and I only provide the original Pantone color name? Their ink techs are going to go to work very hard to get the closest match to my original color. None are going to get close, so each of these examples are the best match they can reproduce. In other words, the lowest delta E to my green. But these greens are all in different directions from my original color. Which one's right? I can accept the reality that the brown craft is not going to allow me to get a match, but I need to make sure that my product matches from all vendors and all their different plant locations. If I don't supply an achievable target, it's going to lead to producing product that'll look inconsistent to my customers. I can't accept widely different results from different suppliers because I gave them a target that nobody can hit. I need to provide a linked dependent target value that is achievable for the specific print conditions that we're going to run. Pantone Live is an example of linked standards that are proven achievable under many print conditions. This way, every ink supplier will target the same linked dependent standard that matches or is associated with my master color every time. Pantone Live dependent standards have been developed for all the Pantone master colors, currently on 42 different print conditions, and they're stored on a cloud server and as a subscription service for various software tools throughout the supply chain. As a result, if we start with a digital standard, or even better, a trusted dependent standard, the ink rooms will achieve a better match to the standard, and the press rooms will also have a better match. And most important, all suppliers in all regions are going to have a better match. This is very important when the product hits the store shelves. Reduced print variation avoids print rejects based on color, and the product looks more predictable and consistent on the shelf. Now let's take a look at how we use the standards in production. So to recap, digital standards are unambiguous and unchanging if managed properly. CXF can be used to distribute custom digital standards, but be careful of the source. Are you working with the original standard, or did someone create a new one with the same name? Got to watch that. Also, Pantone master libraries are distributed through a cloud server directly to applications. And they include the Pantone coded and uncoded, and the pastels and neon libraries for coded and uncoded. Pantone Live provides 42 different standard libraries to reduce the error stack even more by providing known achievable targets to the ink room and the press room. Now, there's no standard formula that can be used for making inks from different vendors for different print conditions. So the digital standards are going to provide the spectral data for the ink formulation software to match with the available ink pigments for the specific type of print application required for your project. The digital standards can also then be added to the quality control databases like ColorCert QA tools, so that each ink batch can be measured for validation prior to the press run to avoid wasted time and materials in make ready. At a minimum, the colors should be loaded into your instrument and then measured during make ready and for periodic color checks throughout the run. For example, the Exact family of instruments have access to all the Pantone master libraries, and with a subscription, you can load the dependent libraries as well. If you're working with other custom standards, you can load the CXF of that color directly into the instrument. The key is to have numeric pass-fail tolerances and provide the operator with actionable feedback, like best match, which will guide them with density or ink strength changes to get to the lowest delta E. In this example, the operator sees that they're currently measuring at 2 delta E, but if they increase the density of this red ink by about 0.15, they can get a closer match of about 0.49 delta E. That's actionable. That's going to get them to color faster. Using a job-based QC application is going to provide a more comprehensive and traceable way to capture measurements of many kinds of metrics for future reviews. This gives the operator a clear pass-fail response And tools like BestMatch provide the actionable guidance on how to adjust the ink density or strength to achieve that lower delta E. And the data can be used to find root cause of print issues so that they can be fixed prior to the next press run. Measuring individual patches can be tedious, and the operator may be less inclined to measure frequently. By using a scanning strip option, this allows the operator to capture more data faster and in turn make the required changes and reduce the waste. For offset printing, measuring all of the ink keys to get color even across the press is critical and can be time consuming unless you have a device that can scan the color bar for the full width of the press sheet and provide key by key feedback for the adjustments. Even better is if your system provides a closed loop integration for automatic press adjustments. Fast adjustments bring the press up to color with less wasted substrate and ink. This is a much more efficient way to bring your color up to color, your press up to color fast than, say, using a handheld instrument. And for flexo and gravure presses, you can add inline inspection systems that include spectrophotometers like those from AVT that are going to measure the color continuously throughout the press run and provide real-time actionable feedback. The holy grail of waste reduction is continuous improvement. In order to find the greatest opportunities for waste reduction, you need to see all your production results and look for areas with common problems in all your jobs. A scorecard server provides a central location to see all of your work. You can look at listed jobs based on the plant, the press, the customer, and you can focus on those with the lowest scores. And that's where you need to look to find your common problems that are going to provide you the best benefit. You can look at each of the individual jobs to see the metrics and the performance of those metrics for each individual sampled measurement throughout the run. You're looking for common issues across multiple jobs and issues that are easy to fix, or issues that are impacting a lot of your work. These things are going to provide the biggest bang for your efforts. Over time, scores are going to improve. You're going to remove the root causes for the errors. Higher scores and less waste will be produced in the make-ready and more progress at eliminating rejected work. As you can see in this real example, the scores in the top line represent the work that we've produced at many locations. And early on, you can see it's very highly variable. Okay, it's all over the place. What looks like a mountain range towards the bottom there, that's representing the amount of work that was measured by all the supplier locations. And as they corrected their root issues, as they eliminated the problems, the scores of the top line improved. Less errors, less waste, more cost-effective production, less environmental impact, more sustainable. So that's what I've got for my part of the presentation.
And that was fantastic, Mark. Thank you for sharing. That was a lot of really great information. So now I'd like to welcome Robert back to talk a little bit more about how his company and how he put a lot of this type of information into practice to improve his own operations. So Robert, if you want to pop back on.
Hi there.
Awesome. So why don't we start off with, can you give us a little bit of background about you and about American Packaging Corporation?
So, hi, Robert Jameson here. So I've been in the industry a little over 20 years, a couple different companies. I've been with American Packaging for the last 7 years. So we are a flexible packaging, predominantly in the flexo market. So we have 3 facilities, and we also do have gravure capabilities, and we have a couple of facilities in Wisconsin. We've had very good success the last several years. So we've had a couple of greenfield facilities that we've built. So I have actually just moved to Utah, and we just started our latest production facility in the last 30 days. So still working off some of the bugs, but a lot of good things going on.
Excellent.
As I've been with American Packaging, I have had several roles, but most of it has been focused on process improvement, and been working with the X-Rite team since 2018 on our color management journey.
Fantastic. So, what were the problems prior to 2018 that you were seeing that eventually led you to using X-Rite's control technology?
So I think some of it's just the evolution of the industry and color management. We were traditionally in a color master environment, and as that technology kind of got to the end of the life, we started to assess what was out there and looking at several different platforms. Ultimately, we decided to go with the ColorCert line. The biggest thing for us is that it allowed us to move away from just looking at spot colors. And we started to then really be able to pull our profiles in, be able to look at jobs and look at the full spectral range of everything that you need to look at on a job. To improve our accuracy, we're able to then dig into the data at that point and adjust if needed our profile performance and really get to the point of or that target goal of one pull and you're off to running. So it really has helped us significantly improve our performance on press and a lot less adjustments to figure out why is this image not looking right.
So it sounds like you've been able to fix a lot of common issues across a lot of your jobs. Do you have any specific examples of how this has impacted some of your applications?
So for us, a lot of it has been, as we've refined standards, more clarity with customers, especially as we get into more of the digital Pantone standards. So it allows us a better representation, and then we're more on an even keel with our customers as far as their expectations and what we're producing. So the biggest thing for me has been that consistency in the manufacturing to give the end customer what they want. We've seen a good reduction in any color complaints, the subjectivity of an operator, perception of that color is acceptable. It really quantifies, and we've really been able to tighten tolerances around what we want them to produce.
So how do these improvements translate into savings and increased profits?
So what has helped us is we've really seen a good, it's been an evolution, but as we've gotten these processes implemented, we have seen decreased color match times. So that's been a really big benefit for us in reducing the, cost impact there. And then external, I kind of hit on that too. External rejections from customers, we've seen a great decrease in that over the last several years with establishing that color expectation up front and what the tolerancing is on it, and then having our operators just manage to that.
So what benefits overall does scorecard reporting bring?
So scorecard has been a big key for me. So the nice thing about the job-based workflow that we're in is I can see a lot more data on a job. And so the scorecard allows me then to dig into that data and look at trending information. We continue to work with X-Rite on advancements there, but it allows me to dig in and look at, hey, do I have a profile that is performing poorly? Is there opportunities that I need to go back and I need to relook at that, reset expectations there? Allows me to manage my operator performance. Are my operators in the day-to-day manufacturing environment following the policies and procedures that we have? And it allows me to kind of catch that earlier versus when I might see a customer impact.
So how challenging was it to set up all of the X-Rite control technology and get your staff trained to use it? Was it a fairly easy transition?
Overall, it was a pretty easy transition. We were able to really migrate a lot of our traditional data into the new system. For us, it was a great opportunity to start to refine a lot of this legacy data, a lot of the poor data, weed some of that out, really work with the X-Rite team on a proper transition plan. And then, it did come down to, it was a good opportunity too for us to implement more training and more education for operators as far as, what are the current industry standards and expectations and elevate their capabilities. But overall that, the change management side, which is always a challenge, but the transition was pretty simple.
So how fast did you start seeing results once you implemented the system?
So we started to capture results pretty quick individually. It's one of those things that it seems like color management's an ongoing evolution, and you're never at the finish line. You just keep progressing forward. But we continue to see, to the slide Mark had a minute ago, more and more refinement, more narrowing of that variability in our day-to-day manufacturing, especially as we look at now we have 3 facilities that we're managing and trying to ensure consistency between them so that I can produce a product in any one of them and have the same result.
So how important is it to you to reduce waste along with achieving that consistency, and has this product really helped you do that?
So yes, waste is always a big proponent for us. Waste, just in reducing the amount of color pulls. If I can get more, consistent data that tells me that our process is in control, then we can, that one pull and get into production. It's significantly less waste. But we've also seen good impact even in our ink rooms as far as reduction of our ink inventories and things, so we don't have as much waste ink as we're on press trying to tone and get those colors perfect.
Excellent. Well, thank you, Robert. So I'll bring Mark back on, and we've covered a lot of ground today. So I think we have time to take some questions from the audience. While we do that, I'm going to throw this poll up on screen. So if everyone can kind of answer it while we go through some of our Q&A. I guess our first questions to get us kind of kicked off is, why are Pantone lab values inconsistent? The lab value for a color may be one value on a device that we use, and a different set of non-matching numbers on Pantone Live. So Mark, can you kind of answer that?
Sure. So it's not knowing exactly which devices or software you're talking about here. I'm going to throw kind of a broad discussion about this. So historically, prior to 2010, Pantone released periodically different LAB values for their colors. Their libraries changed. They changed their LAB values. Starting in 2010, they locked those numbers down. So 2010 on, if you've got libraries that are created after that, they should be the same across the board. So they didn't keep changing. Now the libraries do change. The number of colors in the library will change. They grow, but the colors that were in there before, again, going back to 2010, all the colors from that point forward, once they're established, they stay at the same LAB value. Now there are some other things you may see that could introduce some differences where you see the colors. So there are different, what they call M modes for these colors. There are different methods for measuring them. So, like with D50, with a UV filter cut and variety of things like this. So there's M0, M1, M2, and M3. Okay, different applications will look at those different modes. Now, most of the time in our industry, we're going to use this legacy mode called M0. It's been around for a long time. It's just an unfiltered version of a measurement data. And most of your applications have been using that for years. On the production side, M0 is what we use, or unfiltered. However, if you go into, say, an Adobe application, they have chosen for years to use a UV cut version, or what's called M2. So if you're looking at Adobe applications versus, say, my ink formulation, you may see different numbers there because they're actually looking at different M modes, M0 versus M2. Okay, the Adobe numbers are not to be used in production. Okay, those are meant for screen previews and sending to inkjet printers and so on. For all of our other production, it's always M0. So whenever you get data in your quality applications, your ink formulation applications, you'll be able to select the mode, and again, defaulting usually to M0 unless you choose otherwise. So you should see the same numbers if you're using the latest libraries and you've got the right mode selected. Okay?
Excellent. So Robert, we actually had a question come in for you if you want to come back on screen. So we had, is there a specific application that you're using to monitor the color on your press? Are you using an inline scanner? Are you using a color bar? And then are you inputting this information into an application, or how are you kind of managing all of that?
So we do use X-Rite's color cert software, press side, to manage all of our jobs. And there are a couple of different ways to do that in their either QA tools, which is very close to the old Color Master software, or the job-based workflow, which is what we prefer. And then from there, we build our jobs using our press profile. So try to keep as close to the 0 point on everything as we can. And then we add the spot colors, and then using the X-Rite Exact, we do have the ability then to measure our control strips on the outside of the web, and collect all of that data into the job. Once the operator is done, and we do check that each roll. The nice thing about that software too is that as the operator reads in a roll, we actually print off a ticket that they attach to the retain, so that our supervisors and managers can actually walk through an audit and make sure that they are collecting the data and they're running to specifications. And then that job will go into the scorecard server, which allows me to then see high level, look at reporting. I can dig into a color in the production environment and see over a span of time how are we producing it.
So are there any specific issues that will require you to stop the press when it comes to color?
So what is in the job-based workflow, I can set tolerancing around every individual color. So the biggest thing that we see is that we're just shear or just running off color. When you do your initial pull, allows the operator then to dial in and get it into within the tolerancing, and then they'll go into production. But then any ads or things might throw you off, so then you have to kind of stop and come back and adjust.
Excellent. So Mark, we had one person ask if they should be using the M1 condition if it's available.
Yeah, that's a good question. So the industry, the folks that set the standards in the industry have been pushing for M1 for several years. Okay, the M1 specifies a very explicit D50 viewing condition with a certain amount of UV light in that condition. Okay, and theoretically, it's a great way to go. Okay, and if we started out that way years ago, life would have been a lot easier. Okay, that's where we should be. However, the problem lies in that, like, yes, Robert, he's got libraries for their, colors have been in there for over 10 years, 20 years, that were originally measured with the old unfiltered method, which we call M0. And for someone like Robert to switch everything over to M1 is a huge undertaking. It's not trivial, okay? So M1 is better, but it's really hard to change. Now, what the industry kind of does now is kind of leaning towards more is moving towards measuring your 4-color process, your CMYK inks, using the M1 mode, and while still measuring the spot colors using the M0 mode. So there's some of that kind of mix going on. And if your software supports that, it's not a bad way to go. So like Grackle, Swap, and if you're familiar with some other print standards, CRPC 1 through 7, those are all actually based on M1 measurements. And people are starting to move towards using those, measuring those with the M1 and the spot colors with M0. So I know it's a kind of a long answer. It doesn't give you like a yes or no, but kind of a maybe, and you gotta work with your printer and the brand to come to an agreement. Are we going to move this, and how much are we going to move?
So do the systems need to be calibrated, and how often and how would you go about doing that?
So assuming we're talking about presses here, the presses themselves, periodically, it kind of depends on how much things are going to change, how much the variables change. You do need to do some sort of calibration, okay? So Robert, how often do you guys go through like optimizing and fingerprinting your presses for your kind of production?
Honestly, every time we commission a press, we do that process, and then generally using the scorecard tools, I'm seeing that the data is telling me that we're drifting. And so we've been trying to use those tools and the data from the daily production jobs to drive when we see enough of a process shift that we need to kind of go back and recenter ourselves.
That's beautiful. Yeah, exactly. So you're finding that maybe as the inks or the substrates have changed over time, or as your press ages, variables start to shift a little bit, you actually see that in the data. And so then you can go back and recalibrate to bring things back into your target TVIs or gray balance, whatever you're shooting for, right?
Yep.
Perfect.
And that's
Awesome.
where we use the scorecard a lot.
Excellent. You know, actually, that brings up another point. I've got another customer that also uses the scorecard data for the same kind of thing you're doing, and they're looking at their Flexo, they're a wide web Flexo, and they look at the data to determine the mileage they should expect out of their plates. Prior to having scorecard, they'd run their plates until they just couldn't print anything. They didn't lay down ink right. Now they're able to see that, you know, hey, as the dot gain's going up, maybe we got a lot more plate wear, right? And then it's time to re-image those plates, right? So similar kind of thing. Cool.
So Robert, we had someone ask that based on the fact that the Pantone printed guide can vary so heavily, do you actually create your own visual targets for all of your various jobs?
So when we initiate a new color, kind of like Mark explained, I mean, we will work with our ink vendor to try to get the closest match that we generally have our customers review and approve. We have really pushed in the last couple of years, though, that we stick with the digital standard is what we use in production, though. That is a visual representation for the group or the customer, but we're trying to maintain that zero, where traditionally we would have taken that drawdown that was approved and read that in to create our standard. Well, then now we automatically have shift away from that 0 point, and then your normal process variation in manufacturing, then you're drifting further. So from my standpoint, as much as we can, and sometimes customers are very specific and don't allow you to, I'll put it nicely, but we do, and we're seeing more and more brands and customers buying into using those digital standards.
Cool. And if I could add something to that as well, by the way, keep in mind that those Pantone books are printed, as I said earlier, off of a printing press. And everybody here that's even looked at a printing press, they know there's variation. It goes up or down, colors shift a little bit, right? So with every production, we try to hold to a really tight tolerance. However, there is going to be some movement, okay? Now, what Robert said about going to the digital standard, that's that stake in the sand, right? We print the book to that. Your book may be, you know, left or right of center, and mine's in a different direction, okay? So if I look at the two books, there's a bigger difference, okay? So that's why we, you know, comparing two books is not a great thing. You compare the book to the standard, okay? But ultimately, they're all visual representations of that standard that vary a bit. Robert wants to stick to going to the standard, so we're not expanding that error stack beyond the variability of individual books. We're always going back to the original digital standard.
So it seems like that whole M1 and M0 is really got people questioning. So we had, what does M1 do exactly? Does it filter OBAs? Can there be inconsistencies between M0 and M1, even when OBAs aren't present?
Excellent question. Okay, so let me define M1 a little bit clearer then. So whereas the M0 was what we called unfiltered or legacy mode for all these devices, the M0 mode on any given instrument was basically the illumination of that instrument. So whether it's an X-Rite instrument or a competitor's instrument, the illumination wasn't specified very clearly in there, okay? Specifically, the UV content of that illumination was not specified. With M1, it is specified exactly how much UV content is in that light source, okay? So theoretically, across the board of different instruments, they should be measuring more consistent, even with different instruments, using that M1. A good reason to move there if we can get there. Technically, it's more sound. Now, if I'm measuring a substrate and ink combination that have no fluorescing or no UV brighteners included in them, the resulting measurements should be nearly identical, okay? if I'm measuring something that has a lot of brightener in it, a lot of UV brightener in there, the M1 and M0 will be more different from each other. Okay.
Wow. So do you recommend that the X-Rite exact units are sent in for an annual calibration by X-Rite, or is the monthly calibration done internally, on site, going to be sufficient? What's kind of the best when it comes to those units?
Gotcha. So the instrument, when it comes in for service and its annual certification, they put it into a robot and then measure a set of what we call BCRA tiles. Okay. And they are then adjusted to make sure they come back to a factory standard. Okay. And there's a lot more critical evaluation of the unit to make sure it's performing at its top marks. If you only got that and then we sent the instrument back to you and you started using it, if something happened to that instrument, say a month out from using it, and you weren't measuring on a regular basis to do what we call net profile, it'd continue measuring perhaps, but maybe the accuracy would slip out. So the monthly net profiling takes a look at that instrument. It compares the measurements of that instrument to the factory instrument, and it'll come back with a couple different answers. So either it's nailing the color, no adjustment required, just keep measuring, and it blesses it and says you're good to go. Or another option is it says, hey, your color's off a little bit. We're going to create a little correction table and load it into your instrument to adjust it to bring it back. Or the third thing that's going to be really critical is, hey, your instrument for some reason is way out of tolerance. We're not going to be able to correct it very well. You need to send it in for service. That last situation is the worst case scenario. And if you weren't running Net Profiler and your instrument was far out, you might be getting inaccurate measurements and you not even know it. And it's been 1 month or 6 months out of certification, and that's a way to know that you can trust that your instrument's giving you good color. So do I do one of those or both of those? The combination usually is the best way. Some people choose to go with one or the other, but really the combination is going to give you the best trusted numbers on that instrument.
So Robert, how do you approach customers that have older visual color standards that they're trying to convert to digital colors, knowing that those colors may change slightly? Is that a sales responsibility? Is that a production responsibility? How do you kind of handle that?
So usually we don't pass that off to sales because most of them don't understand color. But it is definitely a collaboration. We do incorporate ourselves in that conversation, but it becomes a pretty big education between either a graphics team and the customer, just to kind of talk about what is the future state of your color. We would love to get you to a digital standard, and it is going to require a shift in the color initially, but then we feel like going forward, if you're sending us a PDF that calls out this Pantone color, then we really feel like that's where we're at. And we have definitely, over the years, created a lot of custom colors. Everybody has the 84, 186 reds, and they're all really close to each other. And we've proactively even plotted some of those and went to customers and said, this is not really going to shift your color, but we are going to start to go to those digital standards because here, and we plot it out and we show them visually representations of the difference. And most of the time it's pretty negligible, but it allows us then, the nice thing that it allows us, if we can get customers to agree to that, is we have one source of truth. So if we run multiple brands that have the same color on the same substrate, then I'm not changing inks, I'm not changing really my target, and then it's just about your plate processes and things and consistency. So we've seen that we can run the same color over multiple brands and not have to change anything.
Awesome. So Mark, we've talked a lot about M1 and M0, but M3 was mentioned briefly. So can you talk a little bit about what that is and what it's measuring?
Absolutely. So M3 is a mode where we put a polarizer filter in front of the measurement. And this actually has one very specific use, is for offset printing, where the print comes off the press, where it's still wet, it's not dried. It's commonly used in Europe. It's not commonly used in North America. It doesn't really have a place in your flexo and gravure printing because those always have dryers of some sort involved. And actually today, a lot of offset has where they're putting down a varnish or perhaps even adding some sort of drying capability to it. So in those cases, it's not even as much of an issue. But anytime you're measuring a press sheet pulled directly off the press, off the offset press, until it dries a little bit, the measurements can change a little bit when you're using M0 or M1 until it does dry to a certain point, whereas the M3, that polarizing takes out that effect. But again, North America, we don't really use that. None of the print standards are really built around that. I guess actually I should qualify that. In North America, where M3 is used, is in offset inline measuring systems that some of your presses have. So like a Heidelberg press, for example, when they're measuring it in the press, it will be wet, and so they're going to put an M3 filter on it. But that'll be used for process control, for adjusting the keys on the press automatically, not for validating did you actually hit the color at the end of the press.
Okay. So many designers build their art files in CMYK, but if they're using a different, rotogravure or a different format on press, we need to make as much of the file as Pantone spot color. So what is the best way to overcome a customer's objection to changing their art files when it comes to their color?
Robert, what do you think about that? I don't mean to throw you under the bus there.
I have not found a consistent answer to that because it seems to be very customer specific. I think, we deal a lot with designers and brands that design a package and have a vision of it, and then they don't really understand the print process to transform that image into the package. And so a lot of times it becomes an education on why we need to do that to be able to print it, and you end up really talking about your industry, the print process, how we have to transform that file to educate them why it's necessary.
Right, and if I could add to that a little bit, the color gamut, the range of colors you can achieve within CMYK, especially on certain substrates we're trying to print on, can be limited. And so if I need a real good vibrant red, I'm not going to get that out of CMYK build, right? So I'm probably going to have that formulated as a different ink, separate ink on press. Okay. What's more is I am going to have more control over that ink in many cases, having it formulated and loaded as a separate ink as opposed to depending on my CMYK builds to match that on press, right? So a lot of times it's just a control or gamut limitation that I need to communicate with my customer, right?
Absolutely. So we have time for one last question. So based on your experience, have the majority of customers in packaging or printing adopted a centralized color server capabilities upstream in their pre-press workflow to manage these digital and analog output devices, or is this something that's still kind of developing?
Yeah, that's a good question. From my experience, what I've seen out there is it's kind of hit and miss. I've seen many pre-media companies and those that are doing the separations and such, using those kinds of tools, okay, color servers and such, to convert files to their specific press conditions and having very good success. But I've also seen a lot of cases where they don't implement that and they do rely on people manually doing the conversions to press fingerprint data and so on. I wish I saw more of it because it's definitely an automated speed improvement. But there are a lot of people still kind of scared of that automation and they want to hand touch every file, right? So right. That's kind of the way it lays right now. I would say we still got a way to go on that.
Awesome. Well, it looks like we are just about out of time for today. So on behalf of Printing Impressions, Packaging Impressions, and X-Rite Pantone, I want to thank everyone for attending today's webinar. Be sure to check out the webinar page to get information on all of our archived and upcoming webinars. And if you wouldn't mind taking just a minute to fill out the brief feedback survey that will appear on your screen next, we would be very grateful. Your feedback will help influence the webinars that we bring you in the future. So I hope to see you all at the next Printing Impressions and Packaging Impressions webinar, and have a fantastic rest of the week.
Thank you all.